Hey girls, I miss you terribly. We're doing 2D, 3D trig at this point in time, and we need you to work through it over the next 2 weeks so that you guys can actually do it in your tests. So, 2 and 3-dimensional trig uses all the trig knowledge that you have learned up until now. It is very important that you know the area, sine, and cosine rules, and these are just grade 11 revision items. So, the sine rule was taking the one side length, so we called it small a, or you can call it BC, divided by the sine of A. Or you could go B over the sine of B, or C over the sine of C. How do you know when you need to use the sine rule? You need to use the sine rule when two sides and an angle has been given. And that angle is not between the two given sides, or if two angles and a side are given. And when using the sine rule, place whatever you're looking for, angle or side, as the numerator on the fraction on top. So if I had to tell you that I have given you C and I have given you B, and I want you to find out what angle B is, you are then going to put sine B on top first. So like this one, sine B on top first over the B, which is equal to sine C over C. I haven't given you anything of A. Always put your unknown at the top. Now, the cosine rule. When we're looking at the cosine rule, we need to understand that you are only going to use the cosine rule when you are given all three sides and you need to find out an angle, or you're given two sides and an included angle. This included angle is your key to understand when you got to use this, because then you'd use the cosine rule. So as a standard, your cosine rule, if you are looking for that angle, the opposite side, A, is used. So A squared is equal to B squared plus C squared minus 2 times B times C cos A. And that's if angle A is unknown. If angle B is unknown, the equation is rearranged to B squared is equal to A squared plus C squared minus 2AC cos B. And the same for angle C. And you guys know this, you've been taught it. Now, the area rule is used when you are given two sides and an included angle and you want to know the area, or you've been given the area, okay? You do not use the area rule in any other circumstance until you understand that the area of this angle, this triangle, if they have the same base and the same perpendicular height as what we learned the other day in trig, then you can make the two areas equal to each other. But unless they're asking you for the area or they've given you the area, you don't use the area rule, okay? And remember that sine has an ambiguous case. What does that mean? Sine rule allows for two different solutions. Now, if you look at this triangle over here, this angle is opposite a side length 60, and it's adjacent to a side length 100. The ambiguous case will only occur when the angle that you are solving for is opposite the longest side. Now, clearly, this is the longest side. And if we want to solve for P, then we're going to have two different P angle sizes. Okay, you use the sine rule to solve for P. So you're going to put P first. You're going to go sine P over RQ is equal to sine R over QP. You substitute the 100 in for RQ. You substitute the 60 in for QP. And you rearrange this to get P by itself. 100 is dividing it. So you're going to bring it up to the top here. And you're going to go 100 times sine 25. Divide that by 60. You're going to arc sine. You're going to bring the sine across, which means shift sine. And you're going to get your angle P, 44.78. But we also know that this could be drawn in a different way. 100 can go over here and 60 can go over there. Keep that diagram in view. This angle doesn't have to be 44.78. This length can come down this way and make this an obtuse angle. So for us to understand that this obtuse angle exists, all we're going to do is take this angle and minus it from 180 degrees, and we're going to get the second angle size that P could possibly be. If the question does not state whether the triangle is obtuse or acute, always provide both possible answers for the sine rule. Remember that the ambiguous case will only occur when you are solving for the angle opposite the longest given side. An acute triangle, there is one where all angles are less than 90 degrees, while an obtuse triangle is one where all the angles are greater than 90 degrees. Where there is an angle that is greater than 90 degrees. This is an obtuse triangle because you have one angle that is greater than 90 degrees. This over here is your acute angle because the angle that you solved for is less than 90 degrees. Watch that video again, see how you feel, let me know what you're thinking. Okay, so here are some practice questions that you can do. Exercise 1 on this I've taken out of my Maths Kevin Smith study guide and handbook. So you can do A, B, C, D, number 2, A and B as revision practice for your sine, your cosine, and your area rules. They want you to determine the unknown variables in each of the following triangles. It's nice exercise to get you into the swing of things. Thereafter, you can go do exercise 6.1 in your textbook to complete and consolidate this information thoroughly. Okay, good luck. Let me see the answers when you're done.